So what exactly is material design? At first glance, it may just seem like a new visual design language full of bright colors and subtle shadows. But it's really much more than that. It's a system that we pioneered that informs all of our visual, interaction, and motion design decisions across mobile, desktop, wearables, and beyond.
Material design is alive. And it lives in a world a lot like ours. A world that's responsive, natural, aware, and intentional. Material design uses responsive animation to create energy. When you take an action, feedback is immediate, and it never keeps you waiting. Motion adapts to the distance an element needs to travel, focusing on how fast something needs to move rather than how long it should take to get there. Motion should feel natural, moving the way things do in the real world. Nothing should instantly start or stop. Elements in motion have momentum and take time to speed up and slow down. They respond to forces like gravity, moving in curved paths instead of in straight lines. Material is also aware of the world around it. The way something enters the screen can affect the movement of everything else. Elements can push other elements out of the way or attract them. Above all, material isn't random. There's a purpose behind every animation. Motion guides you. It keeps you focused on what's important and makes sure you don't get lost. It also hints at how something might react, even before it's triggered. Whether your brand is fun and playful, or serious and straightforward, using the motion principles from material design can help you produce a quick, clear, and cohesive experience. Get to know how things move at design.google.com. But when it comes to motion, it means it immediately and quickly responds to your touch. In material, this response is in the form of an ink ripple and a change in elevation, like when you tap a button. It also means new surfaces can quickly be created from that precise touch location too, like menus when you tap an icon. And it never keeps you waiting. People use our apps to get things done. Tablet screens, for example, may need to have a slightly longer duration, like 400 to 450 milliseconds, to make up for that overall greater distance that it actually needs to travel. Smaller screens, like on a watch, obviously need to move really short distances. It's a pretty small screen. These are often in the range of 150 to 200 milliseconds. Easing is used to add acceleration and deceleration to any type of movement. What's more, our easing curves are actually asymmetrical. This means that each end of the curve is different. Next, material is aware. It's aware of objects around it, behind it, in front of it, and even within it. This allows for a really nice choreographed motion that involves a lot of different UI elements at the same time. As elements transition into view, they take into account their relationships with other objects around them, and they move in a way that kind of demonstrates this hierarchy. This kind of connected movement gives a really nice story about where these objects live and hopefully a better understanding of how the app is actually structured. Surfaces can also push other surfaces out of the way. So if you're familiar with material's elevation story, it describes how each object is at a different elevation. So it only makes sense that if two cards are on the same elevation and one happens to expand or move, it would actually need to push that other card out of the way to make room for it. Either that, or it would need to rise above that other card so it doesn't need to push it out of the way. The important thing to note here is that material can't pass through other material. It knows it needs to do something to make room for it to move. Another concept of awareness is a form of magnetism. This can be a really powerful mechanism in interaction design, and it can really help define relationships and signify whether or not objects are able to interact with each other. In this example, the circle is able to interact with the other smaller circles around it, and as it approaches each one, they're able to attach. Once they move away, they detach, It kind of makes you feel like the UI is doing its best to understand what you want to do. Another material intention is to let you know what's going to happen before it happens. This comes in handy with gestures a lot. For example, if you're using an app where your key interaction is to swipe things away, what happens when you run into an item that you can't actually swipe? You want to add resistance to that item to signify that it's not available. Resistance has to do with how much that object moves in relation to how far you drag it. That way the user immediately knows what they're trying to do isn't available here, even before they complete the swipe. The items that can be swiped have no resistance and are much easier to move around. It's kind of like it's inviting you to interact with it. Next is natural. So we have these nice easing curves and arc motion going throughout that transition. Third, it's aware. It needs to know that it knows that it needs to lift above the other chips to make room for it. But it also knows what is at that new elevation it just moved to, like that app bar at the top. But let's not forget the polish details I talked about earlier. These are still important. Add in some animation where the user might enjoy it or might not expect it, like changing the icon of a button when you tap it. Reaching inbox 0 is a pretty big achievement, so let's make a big deal about it, right? Maybe it'll encourage you to keep it up, which is coincidentally how we want you to use the app. Or maybe you want to call out a new feature in an app, like adding pit stops to maps. And you really want to show off all the different things you can do with it without having a bunch of paragraphs of text to explain it. Error states are another really fun place to do this. So an error is never really something you want to see, but honestly, like, this kind of makes you feel better about it.